Welcome back to Tea and Code, guys. We're going to be doing the course schedule problem today. It's course schedule 2. So let's have a quick read of the description. There are a total of num courses you have to take, labeled from 0 to num courses -1. You are given an array of prerequisites where prerequisites at I is equal to AI BI indicates that you must take course BI first if you want to take course AI. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Return the ordering of the courses you should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. So for example, so we have two courses here, 1 and 0. So what it says here is that we need to take course 0 first before we take course 1. So there we go, 0, 1. And similarly here, we need to take 0 before we can take course 1. And we also need to take course 0 before we can take course 2. So that's that. And then before we can take course 3, we need to take course 1 or course 2. So then the valid ordering would be 0 first, course 2, course 1, and course 3. And the valid ordering would be 0, 1, 2, and then course 3. So there we go. 2000 number of courses, and prerequisites is number of courses squared effectively. So effectively n squared for the number of prerequisites. So this is a graph problem, and this can and also is also a sorting problem. So nothing better to use in this case than topological sort. So let's give it a try. So we'll start by creating an adjacency list. So create an adjacency list. So we'll do that now. So list. So I want to import Java libraries we'll need. Just use Java, all libraries in Java util. List. Integer. So I want to create an adjacency list. So here we'll just do int I equals 0, I less than number of courses. So here we create the prerequisites. We create the adjacency list using the prerequisites. because of the way, because of the prerequisites in this graph, if there's a cycle, if there's no valid answer, it could be because of a cycle. So if we have a cycle, that there's no valid ordering of the courses. So we need to make sure that we can detect the cycle in the prerequisites, in the ordering of courses. So we'll take cycle. So if I'll check if this has been visited, and then so we want to use the text cycle utility function here that will use graph coloring to process each node, because to detect a cycle, we want to move on to the other nodes if the node has already been processed, and if we return back to the same node, we'll need to signify that, so then we know that we've reached a complete cycle. So let's give it a try. So just comment coloring. Has been processed. So that's that. So did. That's that. So here we mark it as visited. Mark as visited. cycle. Turn true. So visited 3 equals 2. So now once we've checked it as a cycle, we mark this one as processed. So so this is now a process. Mark as processed. Then return true. If we detect the cycle, if we don't detect the cycle, we're going to return false. So let's check this real quickly. Set true, return false. So look, util. Visited. Cycle. That's that. So if we detect a cycle, return empty array. Empty array, because there's no valid ordering of the elements. So if text cycle null courses and visited the cycle null courses and visited. So now we're going to actually order the elements using topological sort. So we'll need a stack and a Boolean array. So that's that. Sort. So that's that. So yeah, topological sort, so we're gonna mark once it visits the node, we mark it as true. Then we find the next element, the next the minimum element, so that we can also add the current element to the stack, so that we can order the elements. So let's do that now. So there we are. Very good. So topological sort here. So DFS visited visited and stack here. Very good. So now that we've sorted the prerequisites, what we want to do is we're going this the stack is in reverse order, so we need to reverse it again to return the results. So to go into initialize a array. I think I'll call it output. Stack is MC. Alright, so there we go. So our output number of calls. So let's give it a run. Quick. Good. And again. So accepted. Perfect. So there we are, guys. Topological sorts for the prerequisites. If you have any questions about this implementation of topological sorts, leave it in the comments below. Otherwise, like, share, and subscribe. Thanks for watching.